Alright, before we proceed further, this is the question for you to read up again just in case you need to refer to. So recap it a bit, we have determined a couple of things. The belt B81, okay, this is very important. We have determined 240 big pitch diameter, 120 small diameter, right? Okay, and CA is 742 if I'm not wrong, but this one is won't be in use anymore. Okay, what you need to take note will be the speed is 1440725, all right, and the design power, all right, what is the design power? 14. So this video and next videos we will talk about the number of belts needed. So how to determine the number of belts needed for the systems or the questions? First thing first, we need to determine the rated power per belt. Alright, this video will talk about rated power per belt. And the next video and the last video for that will be determine the power correction factors. There are two correction factors to determine the out of context and the belt length correction factors. After you determine the correction factors, using these two correction factors, you were able to determine the corrected rated power per belt. Then from there, you will use this data to obtain the number of belts needed. Okay, the subsequent two videos will guide you how to achieve and determine this. Can you go to table A1-7? From the appendix, table A1-7, it will be for B belt power rating, right? There's a B belt. So please take note that you have to use the correct belt section table for every other questions. So if you go to A1-6, I believe it should be for A belt section, A1-8 C belt, and A1-9 D belt. Alright, so just take note there are 4 different tables for different belt section. So it depends on which belt section you required. In this case, the example here, we are using B belt, so that's why we refer to A1-7. Okay, looking at that is the column here from the table, RPM of the faster shaft. The question given is 1440. So if you move towards the first few numbers, you will see 1425, which is closest to 1440. Alright, and on the right hand side itself, there are basic HP, okay, basic horsepower per belt for small pitch diameter. In this case, we selected 120 mm for our small pitch diameter. In this case, we don't have 120. Okay, the table here has 115 and 125. Alright, so I'll be working on 3 scenarios. This first example, we will use 115. Alright, the next one, we will use 125, and if not, we can interpolate. Alright, the actual method is actually interpolate. But then again, the 3 examples will show you why we don't need to interpolate to get the right answer. Alright, so in this case, power rating per belt, based on this, I choose 1425, and it's 3.81 based on 115 mm small pitch diameter. So 3.8, that's where I obtain my 3.8. And where do I get a 0.71? If you move to the right hand side, additional horsepower per belt for speed ratio. So our speed ratio is 1.99. Speed ratio is 1.99, right? We calculated 1.99. Okay, so if 1.99, you just go for 1.99, and actually, in fact, 1.994 in between the last column. 1.5 and above. So same row 1.1425, I move down is 0.71. So this is the additional horsepower per belt. So 3.81 plus 0.71. Okay, so using this 1425 RPM and 115 mm pitch. Okay, so I will get 4.52 horsepower per belt. So this is per belt, horsepower per belt. Why do I need to find this value? Very simple. Using this value, I get my design power. Next option we will look at will be the 125 mm pitch diameter. So using the same table with a similar RPM 1425, the horsepower per belt for 125 mm pitch diameter will be 4.73 as shown here. And the additional horsepower per belt for speed ratio remains the same as 0.71. So adding up both numbers, it will give you 5.44 horsepower. Okay, so that's how we determine. We are doing a comparison. Why we should use 115 instead of 125. And the next option we look at it will be interpolation. So the last option we will use will be interpolating 115 and 125 mm pitch diameter data to obtain 120 mm pitch diameter horsepower per belt. We are maintaining 1425 RPM as constant. So this slide actually talks about the horsepower per belt for 120 mm pitch diameter belt. So when you do an interpolation, and you will obtain a 4.27 horsepower per belt for the 120, and the additional horsepower per belt for speed ratio remains the same. You add up both, you'll get 4.98 horsepower. So this is a summary of the three options we have: option 1, 2, and 3. Option 1 is 115 mm pitch diameter data. Option 2 is 125 mm pitch diameter data. And option 3 is interpolation between 115 and 125. Alright, so you will get a various horsepower per belt: 4.52, 5.44, 4.98. So using these example options to show you actually why we choose, or why we advise students to use the lower pitch 115 pitch diameter. Alright, so let's move on. Alright, we have concluded the power rating per belt selection. For this slide, just make sure that you remember to use the correct belt section table reference. Alright, if it's a A belt section, make sure you use the A belt tables. Right, so make sure that is important. If not, you will get the wrong answer. The next slides or videos we'll talk about will be correction factors, and we're also able to determine the number of belts needed for the design.